In this video, we're continuing off from project 133 and going on to project 134, which is buzzing in the dark. There's what our circuit looks like, and there it is on the board. And with this, we're making use of our PNP and NPN transistors again, along with our whistle chip, our speaker, antenna coil, and our photoresistor. And essentially, we're making a variable buzzer, because the photoresistor can change its resistance based on the amount of light going into it. And we're also going to do projects 135, 136, 137, and 138 with this same circuit. But let's start with 134 like it is now. See, it makes a high frequency buzzing sound, but as I change that resistance, we get kind of a ticking sound. And if I let the light back in, so that's how project 134 works. Now when we do project 135, I just disconnect this. I'll leave these jumpers here because that's for a later project. So in project 135, we just remove the photoresistor and instead we just contact our fingers across the points where it used to be. And see, now it's making a ticking sound just for this touching across the points here. And the reason that happens is because your body is able to conduct a small amount of electricity through it. And by doing this, I can activate the transistor there, so we can hear a sound out the speaker. So that's how project 135 works. Now let's move on to project 136, because I gotta make a modification to this circuit. So here we are with project number 136, and that's the high frequency touch buzzer. The one we just did before was the regular touch buzzer in project 135. And with project 136, we removed our speaker and replaced it with our 6-volt lamp. So now, when we have the circuit on, see, we can hear the buzzing sound, but it's a lot quieter because it's coming out of our whistle chip this time. And the camera, I don't know how well it's picking it up, but you should be able to hear that out of the whistle chip. So that's how project number 136 works. So now we're moving on to project 137, which is the high frequency water buzzer. And for this, we connect our jumper wires across the 2 points where we had our photoresistor. And we're also going to need a cup of water. So then we place the circuit a little bit over, have our cup of water here, put one of our jumper cables down in there, and put our other one in it. And you should be able to hear that through the whistle chip. We've got that high frequency buzzing sound coming out of the whistle chip because the water is able to conduct that small amount of electricity through there to get our NPN transistor to activate. And then we hear the sound out of the whistle chip. So that's how project number 137 works. Now we're going to move on to project 138. And with that, we're taking our photoresistor and we're putting it back across the points. But we're leaving our water connection there with our jumpers. In project 138, according to this, is the Mosquito. So let's see what happens this time. Now our photoresistor changes it a little bit, but the frequency is different. Now, of course, I don't know exactly if it really sounds like a mosquito, but that's what the project calls for, is the photoresistor with our jumper still in the water. So that's how project number 138 works. So let's move on to project 139. So here we are with project number 139. It is the high sensitivity voice doorbell. There's what our circuit looks like. And there it is on the board. And it makes use of our music integrated circuit along with our whistle chip and our 6-volt lamp, along with our resistor and our microphone. Now the way this works is that it's using the microphone as the trigger mechanism for the music IC. So when we want to trigger the music IC, we can just clap or do something loud near it, and it should activate the music IC. And again, we can keep on doing that, and it will just repeat every time the microphone picks up a loud sound. So that's how project number 139 works. Let's move on to project 140. So here with project 140, which is the Louder Doorbell. And again, project 141, 142, 143, and 144 are all going to be modifications of project 139. So anyway, with project 140, we remove our 6-volt lamp and we replace it with the antenna coil. And by doing that, we can get a little more current through our whistle chip, and our sound should be louder this time. See, it's louder through the whistle chip, and again, our trigger is still the microphone. So that's how project 140 works. Let's move on to project 141. So here we are with project 141, which is the very loud doorbell. And with this, we've removed our antenna coil and now replaced it with the speaker. So now our audio is going to come from the speaker, and it'll be louder than the whistle chip. And again, we can keep on repeating it with the microphone. So that's how project 141 works. Let's move on to project 142. So here we're at project 142. It is the doorbell with button. And with this, we've removed our microphone and now replaced it with our press switch. So now when we want to trigger the music IC, we have to press the press switch. And again, the music can keep on repeating as long as you press the switch. So that's how project 142 works. Let's move on to project 143. So here we are with project number 143. It is the darkness announcer. And with this, we've replaced our press switch with the photoresistor. And what it does is it signals the music IC when it gets dark. So I've got a flashlight turned on, placed over the photoresistor right now to simulate that it's getting light. So when the light goes off, the music will play because the resistance changed in the photoresistor, thereby triggering the music IC. So that's how project 143 works. Let's move on to project 144. So here we are with project 144. It is the musical motion detector. And with this, we've taken our photoresistor out and we've replaced it with the motor. And when we want to activate the music IC, we just move the motor a little bit. And again, it'll repeat if I move it again. And the reason it's able to activate the music IC is like in previous projects where we've done something with the motor. when you turn the motor by hand, it acts as a generator, and we induce a little bit of current in it, and that is just enough to set off the trigger for the music IC, and that's what allows it to play the music when we turn the motor. So that's how Project 144 works. Now let's move on to a new project with Project 145. So here we are with project number 145. It is the radio musical arm. There's what our circuit looks like. And we're also going to be doing projects 146, 147, 148, 149, and 150 with the same circuit. Anyway, that's what it looks like on the board. We're making use of our music IC, our NPN transistor, our variable capacitor, our antenna coil, and our red D1 LED. And like our Space War radio project that we did in a previous video, this is transmitting the music IC's audio signal through the antenna coil so that we can pick it up on an AM radio. So I've got, again, the little Radio Shack AM radio here, and I've already pre-tuned this to here so we don't have to do that step. So what I do is I'll turn on the radio here. And again, we got static right now because it's not generating a signal. And we've got our jumper wire connected between our points here, between our NPN transistor and down here at our music IC. So the current is just flowing through here and not through our transistor activating the music IC. So when this connection here with the jumper gets broken, when the jumper wire gets broken, the current can then flow through the NPN transistor's gate, activating the music IC, and then it transmits its audio signal that we hear over the AM radio. And the way it's set up on the music IC, it will continuously loop until this is put back on here, disabling that trigger. So that's how project number 145 works. So let's move on to project 146. So here we are with project number 146. It is the daylight music radio. I can't show you the manual because I've got my fingers stuck over the photoresistor here, and that's what we're doing in this project is we've taken our 100 kilo ohm resistor away and we've replaced it with the photoresistor. So now our music IC will only trigger if there is light in the room. So again, I'll have my Radio Shack radio here. Turn it back on. And again, since I'm covering the sensor, it's thinking it's dark in the room, but then once light is introduced, it'll play. So that is how project number 146 works. So let's move on to project 147. So here we are with project number 147. It is the night music radio. And with this, we've put our 100 kilo ohm resistor back in place of the photoresistor where it was over here with our NPN transistor, but now we've got the photoresistor over here connected between the points where we had our jumper wire. And so this time, instead of the music IC triggering when there is light being detected, it will actually trigger if it detects no light. So it's doing the opposite now. So again, that's why I got the flashlight turned on and placed over it right now. Get my radio back over here, and when we take the light away, Now there's an interesting effect going on there. You notice how the music IC was playing slower? There was just enough difference in the resistance there to actually make it play slower. Let me get it flooded back here again. And I can only do it one time. There. It's just an interesting effect. I noticed that it's got just enough resistance to make the music IC work, but it also works slower. So that is how project number 147 works. So let's move on to project 148. So here we are with project number 148. It is the night gun radio. And there it is on the board. And something I want to mention really quick, when I was doing projects 145 through 147, I forgot about this little 2-snap piece that goes over the NPN resistor on the music IC. So on those projects I'll probably have an annotation or a little reminder before in the video about that, but I didn't have that on there. It didn't affect it, but it had it on there. Anyway, we've replaced our music IC now with the alarm IC, so we get a different sound effect out of it. So this time, instead of the music IC playing that birthday song, this time when we cover up the photoresistor, we'll get the machine gun sound effect out of the alarm IC. And it'll continue doing that as long as it's sensing darkness. So that's how project number 148 works. So let's move on to project 149. So here we are with project number 149, which is the radio gun alarm. As there it is on the board, it's essentially the same as project 145 with the radio music alarm, where we've got our snap wire connected in there. So again, it's the same thing. The current's flowing through that and not through the transistor, so our alarm IC never activates. But once this circuit is broken here, our alarm IC gets power and it starts sending the signal which we pick up on our AM radio. So that's how project 148 works. Let's move on, well, project 149. Let's move on to project 150. So here we are with project 150. It is the daylight gun radio. And again, it's the same as project 146 with the daylight music radio. We've taken our 100 kilo ohm resistor away and we've replaced it with the photoresistor. And so now, turn my radio on here. So now, instead of going off when it senses darkness, it goes off when it senses light. So that is how project 150 works. So let's move on to project 151. So here we are with project number 151. It is the blow off a space war. And there's what our circuit looks like. And there it is on the board. And the funny thing was, before I did the recording of this project, I always test out the projects first to make sure they work. And for some reason, I built it the way they had it in the manual, and I couldn't get the circuit to work. And then it dawned on me, it's because I'm using this B6 adapter. They have an interesting way of how this circuit is powered, because the circuit, let me show you in the manual, even though it shows the 2 batteries, you automatically think, okay, this circuit uses 6 volts. Well, actually, this circuit uses 6 volts and 3 volts. That's the thing, because this section here is actually using this battery pack to get 3 volts through here, and then the rest of the circuit is 6 volts with the other pack connected. So that's why it didn't work at first, because I didn't have it connected up with this right. So we had the 6 volts there, and then my 3 volt output from here is going into there. So now the circuit works. That was just a funny thing I noticed, because it was something I noticed on there, that it's using 3 and 6 volts on that same circuit. So anyway, when we turn it on, we hear the Space War IC, and it plays over and over continuously. And what we want to do is shut off the Space War IC by blowing into the microphone. So take this, blow into the microphone here. Now again, it sort of tries to do it, but it doesn't do it exactly well. But that's the point it's trying to do, is disrupt the power going to the Space War IC by changing the resistance through here. But anyway, that's how project number 151 works. So let's move on to project 152. So here we are with project 152. It is series lamps. Here's what our circuit looks like. And there it is, how I have it on the board. And with this project, we connect our 6 volt lamp and our 2.5 volt lamp and our slide switch all in line with each other on one line. And when we flip the switch on, our 2.5 volt lamp starts off bright and then gets a little dim, and then our 6 volt lamp comes on, but it doesn't light up bright. And this demonstrates how circuits work in series, as they're all sharing the voltage drop across them. And like Christmas lights, if one of these becomes disconnected, the other one goes out. Because in a series circuit, it's all one path. So if something is broken in that path, the whole circuit is open and nothing will turn on. So this is how project number 152 works. So let's move on to project 153. So here we are with project number 153, and it is parallel lamps. Here's what a circuit looks like. And there it is on the board. And unlike project 152 with the lamps in series, the lamps are in parallel. So each lamp has its own leg, or loop, that it can travel on. And we're running on 3 volts this time instead of 6 volts like we did before in the series. So when I flip the switch on, our 2.5 volt light comes on bright, and our 6 volt light comes on, but it's still dim because we're only running on 3 volts. But again, with the lamps in parallel, if one of the lamps becomes disconnected, well, the other lamp stays on because it has its own loop that the circuit can travel through. So if something becomes broken, it's not going to affect the other because it's on its own individual circuit. So that is how project number 153 works, and that concludes this batch of Snap Circuit videos.